Today we're going to be working on Leetcode question number 95, unique binary search trees, part 2. So we have been given integer n and return all the structurally unique binary search trees which has exactly n nodes of unique values from 1 to n. Return the order, return the answer in any order. So yes, the way we're gonna be doing it using the using the recursive method. And so initially we're just gonna have a base case where if the n is less than 1, that means you can just return an empty array. If that is not the case, we're gonna be calling a helper function, and the helper function is gonna take where we want to start. So the first value, or the minimum value of the least node we're gonna have, or the node with the least value we're gonna have, is 1. And then we're gonna have how many total number of nodes we're gonna have, so total n, and we're gonna return whatever this helper function returns. We're gonna be returning that, and our function is gonna be like function helper. It's gonna take like the value and the total. So we can call it what is the current value and what is the total here. So the first thing we want to see is like if the current value has become equal to the total, what we want to do is to return an array with only one value, which is null. Otherwise, if that is not the case, what we're going to be doing is like we're going to create a result which is empty, and then we're going to have a two for loops, one where the root is going to start from it's going to start from the value, okay, and then the root is going to go up to our n, the total number, root plus plus, okay. Then we're gonna have another for loop where we want the left side and the right side, so we're gonna have total of 3. So we're gonna have another left. So the left is gonna be like we're gonna say of we're gonna call that helper function with the value, and this time the total is gonna be is less than 1. The total is gonna be total minus 1. Okay, we're gonna do the same thing for let right of helper, where this time the value is gonna become equal to the this is the root. So we are actually traversing from the root, so the root is going to be equal to root minus 1, and this time we're going to have the value equal to root plus 1, and then the total. So one time we're actually keeping the current value the same, and the total value equals to root minus 1, and the next time we are, for the right one, we are doing the root plus 1 and the up to the total one. Now we are gonna have a new node which is gonna be equal to new tree node, with the value root, this new node dot left can become equal to left, and then the new node dot right is gonna become equal to the right, and then we're gonna push this new node. Okay, in the end we're gonna be returning the result. So we have our base case. We are calling the helper function with initially 1 and n, and then in the helper function we are actually taking our root from v to the current value to the total number of values, and every single time we're gonna get a left from that helper function. When we're taking the left from the helper function, the value of the helper function are gonna go from the current value to the root minus 1, and for the right it's gonna go from root plus 1, which is the current value, and the total is gonna stay the same. So let's do that. And let's see if it passes all the test cases, and it does.